Hello friends. Students, you have completed your standard 8 with flying colors. Now, as you have entered in standard 9, for that congratulations. Today in this session we will discuss about our science subject. Okay, but of what topic we are going to discuss, that you have to find. It's like a dumb sharas game which we have played many times. You have to identify that what I am doing. Okay, so let's start. Don't worry, there is not any problem in video, but what I have done, what you observe, that what I have done, many of you will have a common answer that sir, something was going in slow motion, right? So yes, you guess right, that we are going to talk about chapter number 8, that is motion. Okay, so first of all, have we seen anything in motion around us? When we observe the different objects, we will see that some objects are stationary, when some objects they are in motion. Suppose a car is passing by us, so we can say that okay, so car is in motion. Electrons, they also continuously rotate around the nucleus, so electrons are in motion. Butterflies and birds, they fly here and there, so it is also one type of motion. As right now I am moving from one point to another point, that is also motion, right? So motion we have seen everywhere. So two things, stationary objects and the objects which are in motion, we have to study about it. Okay, so what is motion? First we will try to describe that what is motion. Now see how we can define the motion. Okay, if I say that at one time I am at one point, and as at other time I will be at other. So you will say that yes sir, you are in motion, means you are changing your place completely with respect to time. So if any object, it changes the place with respect to time, we can say that particular object is in motion. So what is concept of motion? Try to understand that when object changes its place respect to time, when any object it changes its place related to time, respect to time, so we can say that particular object is in motion. Now actually motion is little bit complex concept. How? Suppose we all are traveling in a bus. Okay, as we look outside we will see the tree is moving backward. So is tree moving backward? Okay, if in the same bus we are traveling, and when you look at the person who is sit beside you, right, who sat beside you, when you will see him, you will say that sir, he is stationary, he is not in motion. But if any person outside the bus is observing you and your bus is moving, so he will say that you and the person who is sat beside you both are in motion. So how to consider that the object is in motion or it is not? So for that we have to understand that motion is one type of relative concept. For one object, right, we can have different type of observations. As we have seen, the person, if we take that person who is sat beside us, if I will observe, right, so we will say that it is stationary, but the another person who is standing outside the bus and bus is moving and he is observing that person, he will say that it is in motion. So see here, when we observe, it was stationary. When the another person observed from outside the bus, that particular person was in motion. Similarly, if we observe the trees, okay, so if the bus is moving and when we look outside, we will see that trees are moving backward, right? So for us, the trees are in motion, but the person who is standing beside the tree and when he will look towards the tree, it is stationary. So to decide whether the object is in motion or not, what is necessary, right? So simple, from where the observation is done, that is the necessary thing. Okay, as I observe the person who is sitting beside me, I have observed from this point. So in that case, he is stationary. But the person who is outside the bus and observe, for that he is in motion. So see, as the observation point change, from where the observation is done, it is changed, the concept of motion is going to be changed. So motion is one type of relative concept. Also, we have to understand about this word, reference point. Now, what is this reference point? Yes, you are right. From where the observation is done or from where the position is determined, that is called a reference point. So, from the point from where the observation is done or position of object is determined or position of an object is determined, that point is called a reference point. And as we have taken the example, the person who is sitting beside us, we will observe it, so we will be a reference point for that observation of that particular person, and the person who is standing outside the bus, okay, and he is observing, so that particular person will be our reference point. Okay, so from where the observation is done, that is called our reference point. Now this motion, it can be of different types, right? Suppose we have seen different motion which is in straight line. Some motion, it is done in straight line, means the moving of cars, right? On a highway, the car is moving, so that will move in a straight line. So moving of car, it will be one type of straight line motion. Second, if we talk about different planets, they are revolving around the sun, and different electrons which is also revolving around the nucleus. So circular motion, motion in a straight line, circular motion. Flying of butterfly, it's one type of random motion, right? It is not defined anyhow, so that will be random motion. In this particular chapter, we are going to discuss about this only, that motion in a straight line. Okay, so for describing motion in a straight line, different type of observations which is done. From that observations, we have to calculate different sums, we have to solve different problems, right? Okay, before that we will require another two concepts. First is concept of distance, and second is concept of displacement. So what is concept of distance and what is concept of displacement? Let's try to understand. Now first of all, what is distance? Distance means total path covered by the object. When any of object is in motion, so how much total path it covers, that will be are distance and displacement. The another term is displacement. In displacement, what is displacement? Change in position, that will be considered in as displacement. So in displacement we will have change in position. Whatever change is done in position, that will be considered as displacement. Now let us try to understand this concept of distance and displacement. Suppose here we are taking one example, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and here the another one, 100. Okay, now suppose this is my point O. We will check distance and displacement both. One object, it starts its motion from this point O, it goes to 40 here. Suppose this is my point A. So what is the distance traveled by the object between point O and A? You will say, so simple, it has traveled 40 units. Okay, suppose this is point A, it is going to this point B. Now, what is distance traveled by object between O and B? So simple, you will say, sir, the object has traveled 60 units. If I ask that what is distance traveled by object from A to B, so simple, it was at 40 and it has traveled 60. So 10 and 10, 20. So the distance traveled by the object, it is the total path. Okay. And second, displacement. In same case, we are going to understand the displacement. Okay. Now, suppose the object starts its motion from 0, go to A, then it go to B, and then it returns back here at C. Now try to understand, okay? You will get a difference between what is distance and what is displacement. Now, between O to C, how much distance object has traveled? Again, distance means what? Total path which is covered. So object, it was here. We can assume like this. From O to C, we have to find the distance and displacement both. Okay. So from O, it is moving first to A, then to B, and then to C. So how much will be distance from O to A? That is 40. Or directly we can take O to B. That is 60. So 60 unit it travel. Then again, this is 60 unit. Then from 60 to it moves to 20. So how much? 10, 20, 30 and 40. So it has traveled 40 units more. So how much will be distance? OC distance. How much will be distance of OC? It is simple. We have to add. First it travels from O to B, that is 60 units, and then from B to C, that is traveling of 40 units. So total path which is covered, the 60 and this 40, so it will be 100 units. Okay, this is concept of distance. But if we want displacement, so what will be there in displacement? It's very easy. Displacement means what? Change in position. In that case, we have to consider only the final position and the initial position. Right now, our object is at point C. So this is our final position. Understood? Okay. Where our object was? It was on O. So this is our initial position. In displacement, we have to do final position minus original position. What is final position? 20. What is initial position? 0. So 20 minus 0, your displacement will be 20. Is it clear? Okay. So again, distance from O to A to B and B to C. How much the distance will be? Distance is total path which is covered. O to B it will go, so that it will travel 60, units, and then 60 to it will come back 40 units, right? But the distance will be always positive, right? So we are adding this in traveled distance, but in displacement we have to consider the change in its position. For that, final position minus initial position. In this case, our object is finally at 20 and initially it was at 0. So 20 minus 0. This way we can consider here. Now, we will take different other examples, so we will have a clear concept of distance and displacement. Okay, let's take different example of distance and displacement, so it will clear our concept about distance or displacement. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, now we will consider different examples which will clear our concept about distance and displacement. Suppose this is our point, same as in that example we have discussed, that it is 0. It moves to point A, which is here at 60. Okay, then the object or the person, it goes to point B, means this 40. In this case, we have to find out the distance between OB, means the object has traveled from O to A and A to B, and we have to also find out the displacement. Okay, so let's do distance of what? Of path O to A and A to B. For that, what we have to do? First distance, it is moving O to A. So what is distance of O to A? You can see that it is 0 and 60, 0 to 60. So O to A. Then we have to add A to B plus AB. Simple. O to A, it is 60 unit, and AB, how much units are there? 10 and 10, 20. So plus 20. You will get 80 units as your answer. Same case we can do for displacement of what? O to A to B. Okay. In displacement, what we studied? Displacement means change in position only. So in such case, we will have final position minus initial position. Now, O to A and A to B, right now what is final position of our object? It is at B. So final position, how much it will be? Final position is 40. And initially, where it was on O, so that is 0. So the displacement will be 40 units. So I hope you have cleared the concept of distance and displacement. Distance will be always positive, while displacement, it can be positive also, it can be negative also, or it can be 0 also. If the object has done motion, so its distance will never be 0. Okay. Let's take another example. Suppose if in this case object is moving from this B to, it is moving this C. Okay, so now our object is moving from O to A, A to B and B to C. In such case, how we will find it? Let's say distance of what? O to A A to B and B to C. Means we have to find out the total distance. Object is starting its motion from O to A. It is going from A to B and B to C. So here what we have to do, find out distance O to A plus A to B and plus B to C. Okay, let's check. How much distance is O to A? That is 60 units plus A to B. Here you can see that 60, 50, 40 means 10 and 10. 20 units plus B to C. Here you can see 10, 20, 30 and 40. So 40. So what is total distance? 120 units will be our total distance. And in same case, let's find the displacement. Okay, displacement of what? Displacement of O to A, A to B and B to C. Again, displacement means only final position minus initial position. So final position minus initial position. What is final position? Finally it is on C. So C, it has 80 unit. Initially it was at 0. So 0. Our answer will be 80 units. Okay, so this way we can find out different type of distance and displacement by given concept. Suppose if we take another example, if I travel 10 kilometers in north and come back 10 kilometers at my home, so what is my total distance? So it says 10 kilometer you went and 10 kilometer you came. So your total distance will be 20 kilometers. But what is my displacement? Have I changed my position? No. So my displacement will be 0. Let's take another example. Suppose your home and your school, it is at distance of 5 kilometer. You went to school, right? So what is your distance? 5 kilometer. Displacement here also 5 kilometer. You come back to school, you come back at home from school. Now, how much is your total distance traveled? 5 kilometer you went and 5 kilometer you came back. So your total distance will be 10 kilometer. But what is your displacement? So finally where you are? At home. Initially where you are? At home. So simple. Your final and initial position is same. So in such case, a displacement will be 0. So by calculating this type of problems, we can have a clear concept of distance and displacement. Okay, so thank you.